Remember that in one of our previous lectures on recommender systems, we say that there are several disadvantages on content-based recommender systems. And one of them is that finding the appropriate features is very difficult. For example, for images, movies, and music, these are all very high-dimensional content and it will be very difficult to extract useful features from this content. And the second disadvantage is that it can be very easily suffering from over specialization. That means this kind of method will never recommend items outside of the user's content profile. And people might have multiple interests, but content-based methods, it's difficult for them to incorporate this kind of interests. And also, they're unable to exploit quality judgments of other users. And on the other hand, we have the collaborative filtering approach. This is the second type of recommended systems that we talk about. And it also has its own disadvantages. For example, it can be subject to user co-star. So it basically will need enough users in the system to find a match and to perform well enough. And also, similarly, it can be suffering from item co-star problem. So basically, it cannot recommend new items that have not been previously rated. The third disadvantage is the sparsity problem. So basically, the user or ratings metric is very sparse and it's very difficult to find users that have rated the same items. And the fourth one is the popularity bias. This cannot recommend items to someone with unique taste because the collaborative filtering tends to use the quality judgment of other users. Basically, that means it will be subject heavily to the popularity bias and tends to recommend popular items. And then we say that there might be a hybrid approach that basically tries to add content-based methods to the collaborative filtering methods. Basically, what we're trying to get the best of both worlds. For example, we can incorporate the item profiles so that we can solve the new item problem or the item co-star problem. And we can incorporate demographics, basically user demographics information to deal with the new user problem or the user co-star problem. But even we do this, finding the appropriate features is still difficult. Imagine that you are trying to develop a hybrid method for recommender system to recommend images or movies or music. And then to come up with a set of useful features for these very complex content, it's actually a non-trivial task. So in this mini lecture, we will talk about a series of deep learning based approach to address this problem. And these series of deep learning based approach, they all come from a unified framework, a framework what we call Bayesian deep learning. And basically in this Bayesian deep learning framework, we will have two components. We have a deep component, which is here, and we have a graphical component, which is here. And you can think of the deep component as just a probabilistic version of a deep neural network. And this deep neural network will help us to automatically extract useful features from the items or from the users. And you can think of this graphical component as trying to describe the relationship between the user factors and the item factors and the ratings. So basically, in any model under this Bayesian deep learning framework, we will have these two components. And here, we separate these variables into three sets. We have the deep variables, and these are the variables inside this deep component. And we also have the graphical component, graphical variables, sorry. And these graphical variables are the variables that inside this graphical component that has no direct connection to the deep component. And some examples of these graphical variables include like the user factors or the item factors in the collaborative filtering method. or the matrix factorization-based method. And we also have the third set of variables, what we call the hint variables. And these variables are the variables that are inside the graphical component, but they also have direct interaction to the deep component. And we need this because we need these two components to be connected to each other, such that these two components can be jointly learned. Basically, this enables us to train the model end to end. So next, we will talk in detail about how to use this Bayesian deep learning framework to design several different models for the problem of recommender systems.